So what we have here is an interesting question where there is a bunch of masses M1, M2 and M3, and they're strung up the way it's shown in this diagram, and the entire system is attached to a rigid wall. Another piece of information given in this problem is that the tension in the string is T1, T2 and T3, and the values of these tensions are also given. So the problem is asking us that given this information, what is the value of mass M1, M2 and M3? Now, how we approach these problems is to apply Newton's second law of motion on each of the masses individually, which essentially means making free body diagrams for each of these masses. So let's take mass M1 first and draw its free body diagram. Now, you've got to remember that when you make free body diagrams, you focus only on the body under question. You do not bother about the rest of the system, and you apply all forces that are acting on the body for which the free body diagram is being made. So let's go ahead and see what are the forces acting on mass M1. We can clearly see that there is the force of gravity acting on mass M1, which is M1g. We can also see that M1 is getting pulled up by tension T1, and you may want to note that if tension T1 was not there, M1 would have just dropped. So there is definitely some force which is pulling mass M1 up, and that is tension T1. So let's go ahead and write Newton's second law of motion for M1, which says that the net force acting on a body is equal to the product of its mass and the acceleration induced by that force. So for mass M1, we can see there are only two forces acting on it. Let's also write the notation we'll follow for vector direction. We'll say any vector pointing in the downward direction would be negative, and any vector pointing in the upward direction would be taken as positive. So we have tension T1 pointing in the upward direction for mass M1, and therefore we will take it as positive T1, and M1g is pointing in the downward direction, so we take it as minus M1g. And this should equal 0 because it's also given in the problem that the entire system is stationary, which means A is 0, making the right hand side 0. So if this is the case, what you'll find is that M1 is equal to T1 upon G, and we know the value of T1 is 10 newtons, and for the sake of simplicity, we'll take the value of G as 10 meters per second square, which gives the mass M1 as 1 kilogram. Now let's go ahead and apply the same equation, Newton's second law of motion, to mass M2. And once again, we can see that the force acting in the downward direction is M2g. And we can also see that the tension T1 is pulling mass M2 in the downward direction. So while T1 is pulling M1 up, at the same time, it is pulling M2 down. So let's go ahead and label this force as T1. And you can also see mass M2 is being pulled up by tension 2. So we label this as tension 2 because if tension 2 was not pulling mass M2 up, mass M2 would have just fallen to earth. So now we have three forces acting on M2. So let's go ahead and write the equation for mass M2. We have T2 acting in the upwards direction, therefore positive. M2g acting in the downward direction, therefore negative. And tension T1 acting in the downward direction, therefore negative again. Mass M2 is stationary, therefore acceleration is 0, and so we'll equate it to 0. And what we get is M2 is equal to T2 minus T1 divided by G. And if we substitute the value of T2 and T1, what you get is T2 is equal to 40 newtons minus T1, which is 10 Newton. And if you divide this by G or 10, what you get is 3 kilograms. So we've just found the mass M2. Now, let's apply the same formula using the same method to mass M3. So once again, we can see that mass M3 is subjected to a downward force of M3g, and it is also subjected to a pull of tension T2 in the downward direction, and we also know that it is getting pulled up by tension T3. Now, applying Newton's second law of motion to this mass as well, this is the equation we'll get. M3g is acting in the downward direction, therefore negative. T3 is acting in the upward direction, therefore positive. And T2 is acting in the downward direction, negative again. And this once again should equal 0 because M3 is also stationary. And if this is the case, then we can find M3 is equal to T3 minus T2 divided by G. And what we get is T3 is equal to 80 newtons minus T2, which is 40 newtons. And then you divide by 10, and what you get is 4 kilograms. So the important thing to remember here is that when making a free body diagram, mark only the forces acting on the object under consideration. In fact, you even need to ignore the force that the mass itself might be impressing on any other object. You just take forces acting on the object for which the free body diagram is being made.